Hello everyone. This lecture we will be talking about handling multiple aims. This is something that many people find intimidating, but it turns out that there are generally straightforward and reasonable solutions to these situations. We're going to define what multiple aims means in the context of a grant proposal and any study that we conduct, and then we're going to talk about the challenges that arise. Finally, we'll talk about how to plan for them. Okay, let's get into multiple aims. It is common for studies to have multiple aims, as studies often have different hypotheses, which are typically represented by aims. Aims can be thought of as something as you're trying to figure out by using outcomes. If we're studying recovery from knee replacement, for example, then there are many criteria for success: sensation of pain, ability to bend, distance walked, let's say, are 3. There are different outcomes, and each can have its own hypothesis, giving us 3 aims. The aims could be something like determine if a treatment leads to lower levels of pain, determine if a treatment leads to better ability to bend, and determine if a treatment can produce a better predictor for distance walked. You will see more examples throughout this lecture. From a power and sample size analysis perspective, it is important to recognize that all of these aims, as a first step as handling aims, is that you do separate power analysis for each aim. Once you do power and sample size analysis for each aim, you'll see that sample size might be good for one aim but not sufficient for others. The same can be true of the power values you get. As researchers, we are trying to balance the harms and benefits as best as possible with these things, but we will tell you exactly how to handle these issues. So we just ran power and sample size analysis for all 3 aims, and we have some adequate power for some aims and not others, and some adequate sample size for certain aims and not others. What do? We know that we want high power for every one of our aims, so we really have no choice but to find the aim giving us the least amount of power in its analysis and choose the sample size needed to get adequate power. And what we find is that this corresponds to choosing the largest sample size of all the aims. So what's nice is all you have to really worry about is calculating the sample size for each aim individually and then choosing the largest one. That's it. The only problem is that this process ignores the ethical issues and cost issues, so make sure you're aware of this as well. Now that you know what to do, let's practice. We will look at a proposal that has 3 aims. Here is the first aim: to find out if community gardening leads to more fruits and vegetables and all positive things that come from that. So this is kind of a randomized study where some people would take part in community gardening and others would not. And then there's fruit and vegetables intake would be measured. The second aim looks to see if community gardening leads to reduced sedentary time and increased physical activity and reduce age-associated weight gain. This sounds like it would be a multivariate analysis. And finally, the third aim is to explain why there are differences found in diet, activity, BMI, and waist circumference between those that take part in community gardening and those that do not. As we said before, we need to run a power and sample size analysis for each aim individually. So each aim requires its own sample size section for some key factors. What type of analysis and test are you using? And are we doing a multivariate analysis like we discussed before? What is the type 1 error rate? What is the estimated power values we are striving for? If we have any clustering, we need to talk about the nature of the clusters, the number of clusters, and the number of people in each cluster. We also need to discuss the overall sample size for each section, including expected loss to follow-up, sample size adjusted for loss, adjusted size for each randomization arm, and correlations that are accounted for. When you have multiple aims, we strongly urge that you begin with a preface, pointing out that you have multiple aims and telling the reader the structure. In writing grants, redundancy is king, and you want to use plain, simple statements. I'm sure you are accustomed to technical writing for journals where you must avoid redundancy, be terse, and eliminate duplication. Throw that out the window, and when you're writing a grant, duplicate sentences that you've written at the beginning, middle, and end of the grant. The reviewers will appreciate it. Here you can see an example with a preface. Now you can begin your description of the overall sample size. Remember, this is all positive example from a successful grant, so paying attention to this format will be beneficial for you. You can see it discusses the size of each randomization arm, the total sample size, the power, and the expected loss to follow up. Now that we have described the overall sample size, we want to step down and summarize the sample size for each of the aims. This is when you need to refer back to the checklist we had a few slides back and make sure to include each of those factors that goes into sample size summary for each aim. So here you can see some checklist items: the type 1 error rate, the statistical tests, the estimated power, and the description of the clusters. It goes on to talk about anticipated loss to follow up, the adjusted sample size, the sample sizes per arm, and the correlations that need to be accounted for. That should round out our checklist for aim 1. Now we move on to the sample size summary for aim 2. It begins with describing where the estimates were taken from and cites principal investigator of the study as the source of the data that were used, which is a good thing to do in power and sample size analysis. It goes on to describe the key means and standard deviations to document where their values come from and so forth. Here it also describes the separate analyses were conducted for sedentary time and BMI. This was a question we had earlier when addressing the multiple outcomes described. Here, they address it clearly. Now we get into addressing all the factors that were on our checklist from earlier in the lecture: type 1 error rate, statistical tests, etc. Power, cluster description, loss to follow up, adjusted sample size, total per arm, adjusted, and finally the correlation. More description may be necessary to explain outcomes. Remember, you want to be as explicit and clear as possible with these types of things. A key difference is documented, and we are ready to move on to aim 3. Aim 3 begins by giving some background information about the power calculations, including details about the software used. Aim 3 continues by referring to the estimates that drive power analysis and provide how they are presented. Here, these ICC acronyms stand for interclass correlation, which is being documented here. Finally, the missing values from our checklist and earlier are provided, including things like type 1 error rate, power, and sample size. In summary, you have multiple aims. You first have to address the question, how do I resolve the conflict between multiple aims? Our approach is to look at the power and sample size analysis for all of them and choose the largest. So you do a separate power analysis for each aim. So in each case, the sample size analysis for the 3 aims leads to a total of 312, 312, and 240 participants. So we identify the largest of the 3, which is 312, in our grant proposal as overall sample size. As long as there are no ethical concerns, you have handled your multiple aims effectively. Let's do a quick review summary about how to handle multiple aims in a study. As we know, each aim requires its own power and sample size analysis. This leads to issues where you may have adequate sample size for one aim, but the sample size is not perfect for the other aims that are part of the study. To deal with this issue, we suggest that you calculate the sample size for each aim, then choose the largest. Also, remember to include the sample size required for each aim in your sample size summary and show how you identified the largest. That's it for this lecture. Thank you for your time.